And then there will be, because H is not only this one, H is equal to all this. So only the kinetic energy term has given us E1, then this term will also be applied inside H. This will also apply on psi naught R1. So I can write for the next part here that we have plus again a mod square will come in, and then I can write E square over 4 pi epsilon naught, E square over 4 pi epsilon naught, and then I will have to write the terms here like this. Here we are having this is it is written over here. Okay, I have forgotten one thing here. This is having 1 over R1 here, and this is having 1 over R2 here. So this will also multiply with that one. So I will have this thing equal to here, and this I write is psi naught R2 over R1, psi naught R1, and then psi naught R1 with R2 here. So solving this step by step, because for R1 we are having R1 here, then this I can write is psi naught and R2 here, and 1 over R1 and psi naught R1 here, psi naught R1 here, and this in the get notation here, while R1 I will write here, plus this has another term here, and psi naught R1 here, then 1 over R2 here, and psi naught R2 here, and in the bracket notation. Now let me explain this thing so that it shouldn't cause a confusion that why we have done this thing. When I write H here, then H is having all these two included. Now when 1 over R1 with psi naught R1 and psi naught R1, when it is applied here, like when here is psi naught R1 and here is R1 and here is psi naught R1, so it will give us that E1, and E1 I have written here common, so that's why I included the term inside here. When here will be R2 and here is R2 and here is R2 as well, then this will again contribute here to the E1. So I have written them down here first, simplified. I should have done this simplification, but I think it is easy. You will comprehend this thing easily. Then the only term that which will remain here with the E square over 4 pi epsilon naught are the cross term. When R2 is here, then R1 is here, and here you are having R1. And when R1 is here, then R2 is here, and R2. These are basically the cross terms that will survive with A square and E square over 4 pi epsilon naught, and E1 is not coming just like here in this situation. So we have splitted the some portion of H here and some portion of H here with this one. Now here I know that again we are having some cross term multiplication. Like when psi naught will be multiplied with psi naught R1, then it will be psi naught r1 mod square, and they are normalized, so we will get 1 in this situation. But when this psi naught r1 will be multiplied with psi naught r2, then they are orthonormal in their nature, so we will have 0 here. Similarly, for psi naught with this one we will get 0, and for with this one we will get 1 here. So this thing is easy to understand here. While these terms, they are also like the exchange term. Earlier we were having the overlap integral, now these are basically the exchange terms. So the exchange terms will be like we will have to calculate them. Without calculation we can't say anything about this one. So we will have this thing is that this will come out to be equal. Let me start from here. This implies that the Hamiltonian is equal to a square E1 a square a mod square E1, and then we have 1 plus 0 plus 0 plus 1, so it will come out to be 2 here, and then plus a mod square and e square over 4 pi epsilon naught, and these two terms that I have here, let me suppose them with another terminology here, and I will label them is that when we have this thing, I can I can suppose this thing with something, and I can suppose this with another terminology or with another notation, and then we will solve them, because here means writing all the expression that long and solving it is very difficult. There is a lot of mathematics involved here. So finally I can write that H and this E1 is equal to, this will result in 2, because 1 plus 0 plus 0 plus 1 is equal to 2 here. So we are having 2a square E1. First write this one. So this is 2a square E1, and then a mod square e square over 4 pi epsilon naught, and psi naught R2, and 1 over R1, and this in the bracket notation I will have to write psi naught R1 here, and then plus means the plus symbol here, and psi naught R1, then 1 over R2, and psi naught R2 here, and close this bracket here. Now here in this I will suppose a value here. Let's say I suppose that I define D, and D is such that it is A times this. Why I'm taking it A times? Because at the end we will come to know that the calculation become much easier if I do take A here with this one in this supposition. It will simplify the calculation. So A, and then psi naught R2, and 1 over R1 psi naught R1, and in a bracket notation, and another we write x, and x we define the other one, and this is also with a with it, and then psi naught r1 here, so 1 over r2 here, and psi naught r1 r2 here is this. So we have defined two parameters here, is d and x here, and we will solve this d and x here. So our equation remains here, and I will have to write the value of d here. Now d is equal to this thing, so I can write this is a psi a and psi naught r2 and 1 over r1 psi naught r1 here, and this thing is equal. If I do put the values here, like it is the same where we have a rotated geometry along the z-axis, that r1 is equal to r and r2 is equal to r square plus r square minus 2r cos of the angle, and this is in square root. So again with the same geometry, again the sine theta and d theta will come in the r integral. We will sign the sine theta and d theta integral first, and then putting that integral back into the r integral, and we will solve this. So it is almost, you can say, a one-page calculation. So I will share this calculation with you, but I am unable to do this thing here because it is taking a lot of time, but I have done it really step by step, so you will have no problem in this one, and we will come to know that d comes out to be a over r and minus 1 plus a over r, 1 plus a over r, and e to the power minus 2 r over a. This is the value of d that comes out, and similarly when we do calculate the value of x, then the value of x comes out to be, means the value of x is even complex, and it is almost after a two-page calculation we will come to know that the value of x comes out to be, and the value of x comes out to be 1 plus r over a and e to the power minus r over a. So we have found the values of d and x, and then I will have to rewrite the Hamiltonian and put these values back there. But before that one, let me do some simplification, because we are having the involvement of e square over 4 pi epsilon naught. So we want to write the terms in terms of E1, because that will make our calculation much easier. So we know one thing, that the ground state energy of hydrogen atom is E1, and this E1 is equal to minus ME4 minus ME4 over 8 pi 8 epsilon naught square h square, 8 epsilon naught square h squared. We know this thing, and we also know the Bohr radius, which is equal to 4 pi epsilon naught 4 pi epsilon naught, and here we have h bar square instead of h square, and m e squared. So we can convert these two, and in the lecture notes you will come to know that I have converted this thing, and we come to know that E1 comes out to be, this implies that E1 comes out in terms of the Bohr radius is equal to minus E square over 4 pi epsilon naught, E square over 4 pi epsilon naught, and 1 over 2a. So I have written the E1 in terms of A. So this will make our calculation easier. So we are having from the helium ground state calculation, we were having the repulsion between the proton and proton, and that was the VPP, the potential energy due to the proton and proton repulsion. And here we are having the same situation, we are having two protons. So if we do put this one, which is E square over 4 pi epsilon naught and 1 over r, because their distance is r and E square, this is a Coulombic potential energy. Now this I can write in terms of E1 and A by incorporating those equations while done step by step in the lecture. This is equal to minus 2a over r in E1. So I have written this proton-proton repulsion energy in this form. And then I have completed all this, so I will erase this one and I will start with the next clean board here, and I will start with this equation and putting all these values here.